Yeah, so now you can begin.
Yeah. So thanks, Srinivas and the Hack3 team for giving the opportunity to host this workshop. So this workshop is basically about breaking into blockchain. You guys have might have heard about this technological term, which is very new, called as blockchain. Very new to most of the people, but actually this technology called as blockchain came around 10 years or like 10, 20 years back itself, but started gaining traction around 5 years back when actually Ethereum was launched. Okay, so I'm going to demystify the concepts or the technology behind the core concepts behind blockchain and how applications run on blockchain. What is the future of blockchain and how you can break into blockchain, how you can get started with blockchain and build applications or build a career out of this. Okay, so I'm going to do that. Before that, I want to give you a quick intro about me. I'm a Jobin. I'm a blockchain developer evangelist working at Arcana Network. So I'm working full time there. So I basically spearhead all the developer relations and developer community activities there. So a lot of activities such as boot camps, cohorts, and developer side content and hackathons. A lot of other programs keep on happening, and also the developer community activities. So we also have a very strong Discord community of developers of around 25,000 members. So we are really active in terms of putting out content and various types of content which is for the general audience. We're trying to grasp the basic understanding of blockchain and Web3, getting started with the space, or also for the people who are very advanced and want to actually build something really cool on this technology. Okay, so please do follow us on our social media handles, or you can join our community if you want to gain more knowledge or want to involve with other developers, get more ideas or help in terms of development. Okay, you can feel free to reach out to us. So I'll share all these things at the end, but let's start with this session for the moment. You give me a second, I'll share my screen. So Srinivas, could you give me the permission to share the screen, because I see that it's disabled for me.
You should be able to right now. Try it.
Yeah, yeah,
All right,
it's
sounds
visible. Hey Srinivas, give me a second. I'll rejoin. There's some issue with the sharing this, like sharing my tab. I'll just rejoin. Give me a second.
Yeah, no problem. Hey guys, so the workshop instructor had a bit of technical difficulties. Just hold tight for like a couple of minutes and I'll try to get back to him.
Yeah. Sorry, guys, I had to just reconnect so that I could share my screen.
Are you?
Yeah.
Okay.
Yeah. I hope that you guys can see my screen right now.
Yeah, we can see it.
Okay, great. So before moving on with the session, I just want to know uh, from which all cities you guys are joining. I just want to know how active you are. Just want to know from where you are joining. If you are happy to share that and put out in the chat section. Great. So we have one guy from Middle East, Chicago, Houston. Okay, GM. Okay, so looks like we have people from different parts of the world and so various time zones also. So thanks, really appreciate you guys joining the session in spite of the time differences. And actually, I'm joining from India, so it's 1:40 a.m. in the morning. So there's a huge time difference. So I appreciate you guys joining. So yeah, thanks for the response. I'll move on with the slides. Yeah. So what's all this hype about? You guys have might have heard about all these words called as Bitcoin, dApps, cryptocurrencies, Ethereum, Hashgraph, forks, nodes, and all this thing. But all these technologies or all these words revolve around a central technology or an umbrella name called as blockchain. Okay, it revolves around this major domain called as blockchain. Okay, so we're going to cover or disassemble the concepts or the technology behind blockchain, or simply I'm going to demystify what exactly blockchain is. Okay. So what exactly blockchain is, when you try to search on the internet, the simplest definition that I could find and the simplest illustration is this that right now you see on the screen. It's a public chain of blocks containing data with interconnected cubes. Okay, this is the simplest definition and illustration of blockchain that I could find out on the internet. But I don't think so. That's the simplest one. I want to make it much more simpler so that you could remember it forever. And if you want to explain to your sibling or a kid who is like probably 4 or 5 years old, like approaching you, wants to understand blockchain, you'll be able to understand, like make that child also understand what exactly blockchain is after the session. So I'm gonna explain that to you in a very simple analogy. So yeah, here it is. So in simple words, blockchain is like a sequential chain of coaches in a tree. So I hope that all of you might have traveled in train. So a blockchain is nothing but it exactly looks like a train. Okay. So it's a sequential chain of coaches in a train. It exactly looks like that. So let's discover what are the similarities between a train that you travel in and a blockchain that you might have heard in the recent years. Okay, the similarities. Train has got coaches. Coaches are the place where passengers sit and move from one location to the other location. Okay, why we use train? We use train so that people can travel from one location to another location. Okay, so instead of coaches in train, we have got blocks. Okay, and there is something at the beginning of the train, which is called as an engine, which pulls all these successive coaches. Okay, so the first coach in a train is called as engine. Similarly, in a blockchain, all the pieces of the blocks, a blockchain is called as blocks, and the first block is called as the genesis block. Genesis, as you might know in the dictionary, the simplest, what do you call the definition or the meaning for the genesis word is the beginning. Okay, the first block is called as the genesis block in a blockchain. Okay, it's very similar to the engine that you find in a train. And when you buy a ticket to travel in a train, you will receive a ticket with a seat number and a coach number. Why do we have a coach number? So that we can easily identify in which place in the train you have to sit and you can travel. Okay, so for the easy identification of each and every coaches, as so that people don't get congested and don't get confused while traveling and get confused in finding out the proper seats, you have got an easy identification called as the coach number. Similarly, every block has got its own hash. It is exactly similar to a coach number. Okay, so that you can easily identify a block and whatever the data it has. So consider you want to find out Amazon Prime movie or a Netflix movie that you want to watch. So you need to know where it is located. For that, you need the hash of the block. Right? Using that hash of the block, you find that particular block and you access the data inside that. So that is the reason that you have got hash of the block. And similarly, all these coaches in the train all the coaches in the train are connected in an order or in a sequence, like coach number 1, 2, 3, 4, 5, 6, okay, in an order. So probably I don't know how the coaches out there in Saudi or Belgium or in US works, but I believe that every coach might have a identification somewhere in the entry or exit path showing that the next coach is this and the previous coach is this and the current coach is this. I hope that is true. Could you guys put out that in the chat whether it's true? I don't know, because out there in India, out here in India, it's actually how it works. Like there's a coach number S1, S2, S3. So right now, if you're an S2 coach, you'll see an indication at the entry or exit point that the previous coach is S1 and the current coach is S2 and the next coach is S3. Okay, that is how it looks. So is it true when it comes to trains in Saudi or Chicago or Belgium? How's that? I'll wait for your responses for 10 seconds. If not, so I hope that I've been on one yet. Okay. Yeah, so I hope that it's common that you will have somewhere the identification regarding the coaches. Okay, so or else you can have an understanding that for you to easily identify the order in which the coaches are arranged, somewhere you have to put an identification. Similarly, the terms in the US are a bit different, but I can understand. Yeah, the terms might be different, but there is an order, and somewhere it is mentioned that identification mark might be given somewhere to show that this is the particular coach and the next coach is this one and the previous coach is this one. Okay, similarly, to identify a sequence of blocks, like if you are currently in third block and you want to understand what is the sequence, what is the order, or you want to traverse between the blocks, like you want to move to the previous block or the next block, each and every block also stores the hash of the previous block. So this basically shows there is a continuity between the between each and every block. That is why it's called as a chain. Okay, it is an interconnected blocks that forms this blockchain. And the most important thing or the similarity between a train is that trains carry passengers from one place to another place, but blockchains carry data. Okay, instead of passengers sitting in a coach and moving and traveling from one place to another place, okay, blockchain carries data from one place to another place. Trains have limitations, like trains might be what do you call to the max like traveling from one subcontinent to the another continent. That's the longest train I believe exists, the Trans-Siberian one, I believe. That's the longest train. Nothing beyond that is possible. But when it comes to blockchain, you can store a data sitting here in India and somebody out there in the Antarctica or US or South Africa or Australia can access the data. So it's sort of like instead of passengers, data travels from one place to another place in the internet using blockchain. Okay, so that is the basic understanding of blockchain. No, not exactly. It's not a piece of crypto. I'll explain to you what exactly crypto is. Crypto is something which leverages the features or the advantages of this blockchain technology. So crypto is built on top of blockchain technology. It is one of the applications of blockchain technology, but it is not exactly blockchain. Okay, it's different. So you can build a lot of other technologies, cryptos, DeFi's, you can build dApps, smart contracts, even you can build, right now you're using Zoom as a platform for this, what do you call this, video conference or this meeting. You can actually build a video conference or a meeting platform using blockchain. And actually there is one that exists that is called as Huddle. So you can go out there on the internet and search for Huddle, and you will find that it's a metaverse-based blockchain technology using, platform using blockchain technology. Okay, so you can check that out, and it's really secure and decentralized, so you don't have to fear that somebody is snooping or stealing your data, or probably can bombard your meetings. It's completely secured using token. So like you have to get tokens from the person who is actually organizing this meeting, and these tokens are secured using strong cryptographic algorithm called as SHA-256, or secure hashing algorithm 256. So it's like it will take generations and generations to break that what do you call tokens. So until then, the meeting might get over. So there is no point at breaking that tokens. Okay. So I'll come to that part. I'll come to that part in a detailed manner. Okay. For the moment, this is the basic understanding. This is the similarity between blockchain and a train. So next time you see a train, have a visual understanding and get a similarity that this is how a blockchain looks, this is how each and every block looks, and instead of passengers, data travels from one place to another place. Okay, so right now you can see a visual representation on the screen. Okay, so there's a Genesis block, which is in blue color. You can see that the first compartment or the first section carries the previous block's hash. So basically Genesis block will have 0, 0, 0. That means because it's actually the first block, there is no previous block before that. So there is no hash of the previous block stored in that. And it will have its own hash, which is 1Z8F, can have any random number. So hashes are nothing but it's a combination of letters and numbers. Okay. So it's a combination of letters and numbers, which is basically created using algorithm. You can decide whatever algorithm you can run, like probably if it's sort of like creating a username out there on the internet. The internet creates a random username based on your first name, second name, or probably your birth date and everything. Okay, you can create random usernames. Similarly, there's an algorithm which creates this hashes, but hashes are sort of not easily readable and not easily memorizable. Okay, so it is created in such a manner so that you can easily remember that. So security purposes. Okay. So every block has got its own hash, and it's usually in a length of 16 digits. Okay, that is the length. So I have given you a simple explanation where it's only 4. The length is only 4, 1Z8F. Okay, so the second block, you can see second block has a first section where it shows the hash of the previous block, the 1Z8F of Genesis block, and its own hash of the current block, or its own hash in the second section, 6BQ1, and the third section holds the data that you are storing. Okay, so this is how a blockchain looks, and this is the similarity between the blockchain and the train. Okay, coming to the next part, how new blocks are created and why new blocks need to be created. So actually, when trains were invented back in early 1950s or 90s, back then trains had only a less number of coaches. The reason that there was not a huge amount of demand for people to travel in train from one place to another place. Like for a long distance travel, usually people use trains, or else people would use what do you call cars or any four-wheelers or similar sort of thing. Okay, but when people want to travel long distance, they will use trains. So the demand was very less compared to the current situation. So very few coaches, but with the increasing demand, the train companies or the governments or whoever was running the train service had to create new coaches, manufacture new coaches, and add that to the train. Okay, if consider there were only 10 coaches for people to travel, with the increasing demand, they had to create 11, 12 coach, 13 coach, so and so on. Okay, so similarly, consider you want to add more data into the blockchain. You know, out there in the internet, people keep on adding new content now for media consumption or emails or Instagram reels, Instagram posts, Facebook, LinkedIn, Twitter. A lot of content goes out there. So the requirement or the demand is keeps on increasing. So you have to create new blocks so that the data can be stored. So how is the data block created? Okay, that's exactly similar to how a train coach has been created in the manufacturing facility. Okay, Are they 4 characters long? No, Matthew. The length usually for a block is 16 characters. But if you are creating your own blockchain, then for sure you can change that. You can create a secure one, probably with a 32, 64, whatever you wish. Okay. The more the character, harder it is for a person to remember. So harder it is for a person to crack it. Okay. Security wise, people can easily get confused. So the length also determines the security. Okay. 4 character, just a simple explanation I was trying to give you. Probably if I try to add 16 characters here, the illustration will be a big one. So it's not possible. That's why 4 characters only. Yeah. So creation of blocks is based on demand. You want to add new data, you need to create a new block. Okay. So new passengers, more passengers have to travel in train, new coaches will be created. Okay. So based on the demand, new blocks are created or new coaches are created. So the manufacturing is exactly similar to how, or the creation of blocks are exactly similar to how a train coach has been manufactured out there in the manufacturing facility. Okay. So what sort of work is involved when you manufacture a train coach? So the crypto, there's a question. So the crypto that has a static supply means that the currency isn't creating new blocks. So actually, currency doesn't create new blocks, but it's the transactions that happen in the network that creates blocks. So consider, Matthew, if I am sending you 5 Bitcoins, so somewhere the transaction has to be stored. Okay. So the people can keep a track of my balance. I can keep a track of my balance so that if I only have 10 Bitcoin in my account, and if I give you 5, so that I can't fool anybody else that by telling that I have 50 Bitcoin in my balance, I can buy 50 Bitcoin worth of things or NFTs or whatever it is. Okay, to avoid such situations, the transaction, my account balance, everything has to be stored somewhere. So new transactions, when new transactions happen, new blocks are created, and this data of these transactions that are happening are stored in this block in the blockchain. Okay, so that is okay. Static supply, dynamic supply doesn't determine whether new blocks are created or not. It's the transactions that determine whether a new block should be created or not. So I told you the demand. When the demand arises when you want to store a data. The data can be crypto transactions or new NFT images or videos or whatever it is. Okay. So if I wanted to start building dApps, where can I start? I'll come to that part. Okay, Kazi. I'll come to that part at the end of the session. We'll be covering that. Now let's cover the fundamentals so that you have a crystal clear understanding of what exactly blockchain is and how it works. So I believe if you directly start building dApps without having any understanding how new blocks are created, there's a point that somewhere when you actually go in depth and you start implementing something very seriously, you will fail. Okay. So you need to have a really crystal clear foundation when it comes to blockchain if you want to build dApp or write smart contracts. So there is some sort of work that has been involved when it comes to creating or manufacturing train coaches. Okay, what is that work? That work is mechanical work. Mostly mechanical work is involved when it comes to creating or manufacturing train coaches. Okay, so whoever the train owner is or the government is, they will give a structure to the manufacturing facility. Okay, following that structure, like it should have 4 doors or 20 windows and 72 passenger seats and whatever it is. They will give the structure, they will give a format, sort of like a template of creating this coach, and based on that, mechanical work is involved, and this coach is created and handed over back to the train service or whoever runs this train. Okay, and they will add that coach to the train. That is how it works. So when you create a new block, here also work is involved, but here mechanical work is not involved. Instead, your computational work is involved. So your computer actually works to create these blocks with particular data, whatever the data might be NFT images, like I told you, or the crypto transactions or anything. Okay, so the computer takes in all these transactions and creates a block. And here, similar to the train manufacturing, which followed a particular structure or a format or a template, blockchains, the blocks in the blockchain also has got a particular structure or a format or a template. And now you know what the format or the structure is. It should have main 3 components. That is, one is the previous hash of the block, hash of its own block, and the data that is it's storing. Okay, so consider right now I'm doing a transaction with Matthew. I'm sending five bitcoins to Matthew. So this is a transaction. So transaction is the data. So what it will do is, until this moment, only 10 blockchains, 10 blocks were created in the blockchain network. So now there is a demand to store a transaction data. So the 11th block will be created. It will have the previous hash of the block of the 10th block in the blockchain network. It will have its own hash of the block, and the data will be that I sent 5 Bitcoin to Matthew, and now 5 Bitcoin has been reduced from my account, and 5 Bitcoin has been incremented in Matthew's account. This is the data that has been stored in the 11th block in the blockchain network. So this is how it works, and here computational work is involved. Your computer, what do you call? The computer uses its CPU, GPU, and spends electricity to create this blockchain, this block in the blockchain. Okay, so the creation of training courses were called manufacturing, but when you create a block in the blockchain, it is called as mining. Okay, so it is called as mining. So now you know what exactly mining is, how why people what do you call, people tell I have mined 2 bitcoins, or I've created 2 new Bitcoin blocks. Now you know what exactly mining is and how it works. Okay, so now, and the thing is that when you hand over a requirement to the give out the requirement to the manufacturing facility to build 2 coaches, 3 coaches, or whatever the amount is, after they create that or manufacture that and give it back to the train service or the government or whoever it is, they are being paid for that, right? So because the mechanical work is involved, you have to make sure that you get paid for that. Okay. Similarly, when you actually create a block and a blockchain, you get paid for that because you are spending an electricity, you are using your computer's CPU and GPU, and you are spending time. So there's some sort of computational work that is involved, and you have to make sure that you are rewarded for that, or else it's waste of time, waste of money, randomly sitting and storing data by creating blocks. It doesn't make sense. Okay, that is how actually people earn Bitcoin. Okay, so now you are understanding what mining is and how people get Bitcoin when they mine a Bitcoin or mine a block. Okay, so they get paid for adding new data, adding new block into a blockchain. So I have a question, I believe. So why do the CPU and GPU do the same work? Aren't they different? Yeah, actually they are different. So it depends upon the network that is. So every network has different algorithms and different techniques at solving this problems or adding this block to the blockchain. Okay, so if it comes to Bitcoin, then Bitcoin uses GPU because the algorithm is designed in such a way that GPU is the best computational device, or what do you call, the system that can solve this problem and add the block into the blockchain. Okay, CPU is not the efficient one here, but there are blockchain networks or blockchain systems which actually also leverage the computational power of CPU. Give me a second, guys. Yeah. So there are blockchain networks which work on CPU as well as GPU, but majority of blockchain systems on network work on GPU because GPUs are far faster, far efficient, and better in terms of solving problems. When it comes to machine learning and AI, also you use GPU. Okay, so mostly GPU. CPU also is used when it comes to certain parts of computing these models, but mostly GPU, I believe. Okay, I'm not that a machine learning guy, but whatever I've heard about, I've learned about machine learning or AI, that is how it works. Okay, so mostly GPU. So you're spending your money to buy GPU or spending money to buy a computational system rig or a computer rig or a mining rig. You are spending electricity, so you have to make sure that you get paid for that, or else it will not work. So that's why you get paid in terms of Bitcoin or Ethereum or Ether or Coin or whatever it is. Okay, what are the native token of the blockchain network is. So that is what mining is, and that's how you get rewarded. So next, consensus. So this is one of the most important thing, and this is what keeps the network secure from unwanted data or unwanted block in the blockchain. Okay, so consider when it comes to trains, there are only certified or licensed manufacturing facilities who can create this coaches. Okay, and only this train services or this governments uh, outsource or get this coaches manufactured from this licensed organizations or this manufacturing facilities. Okay, not any random guy can come and manufacture this. Okay, so but when it comes to blockchain and the block, any person out there on the internet has a computer who has a mining rig or has access to a decent stable internet connection can come and create a block in the blockchain and add that. So there is a high possibility that people can spam this network, people can add malicious data into this network, which will actually defy the purpose of blockchain. Okay, we are creating this blockchain. If it comes to, if it is a Bitcoin, then it is meant to store the transactions that happen in the block, the Bitcoin network. Okay, so if somebody is coming and adding wrong transactions, like I have 50 Bitcoin in my balance, but I will tell that I have spent 100 Bitcoin and I'm capable of buying more, that's not going to work. Okay, you should not be able to fool people out there using this blockchain technology. To avoid that, there is something called as consensus. Consensus is the technology that keeps the data in check. Okay, so you can't fool people, can't add malicious data, wrong data into the block in the blockchain. Okay, so I have another question. So does mining incur that you sell the coin instantly, or can you keep if the price of the crypto gets higher? It's completely dependent on the markets. Okay, so you get rewarded with this Bitcoin or whatever the token is. You can keep that in your wallet. You can wait for the market prices to increase and you can sell it later. It completely depends upon the market. Now it's bearish. So at the moment, if you the present situation, there is a possibility that if you hold some coins, it can go down. I'm not giving a financial advice. I'm giving a just a situational example. Okay, if the market is going, the market rates are going high, then it's good. You can hold that and gain more profits out of that. Okay, so it completely depends upon the markets. Okay, I mean the market rates of this token basically depends upon the supply, the demand of the coin. The more the demand, more the prices. The more the supply, the less the prices. Everybody is selling, the prices will go down. Everybody is holding, the prices will go up. That shows there is more demand. So that is more of a token economics. Okay, for crypto economics. Now I'm not going to go to that back. Okay, I'm covering more of the technology side of the Bitcoin blockchain. Okay, so consensus. So consensus is that part of the technology which keeps data, or what do you call is basically a watchdog to keep everything in check. Okay, so here the consensus is that because everybody gets a chance to add data into the block and add that block into the blockchain, everybody also gets the chance to judge whether a block has right data or wrong data. Okay, everybody has that ability, or what do you call, everybody has that chance to tell whether the block has right data or wrong data after looking at the data. So if the majority of the people agree to the fact that the data present in the block is right, then that will be added. If majority of the people say no, it's malicious or it's not good for the blockchain network, nobody will add. Okay, so that is consensus. Coming to a common agreement, okay, to add a data or add a block into a blockchain, that is consensus. So there are various techniques to that. There's POW, POS, and DPoS. So there are a lot of other consensus mechanisms also, but I'm going to cover the most common ones: POW, POS, and DPoS. So what exactly POW is? Proof of work. Proof of work is because everybody has a chance to create a block, add a data, and create a block and add that to a blockchain. There is a high probability that people can spam the network, at the same time add malicious data also. And only one person gets a chance to add a particular block. Like if you are trying to add an 11th block into the blockchain network, only one guy can add. The first, it's like sort of like a first come first serve basis. So whoever the person is coming first, solving the problem or meeting the requirements, will get the chance to add the 11th block. So if you are in queue waiting to add block into the blockchain, you can only add in the successive blocks like 12th, 13th, or 14th. You can't add in the 11th one because the first person to come only gets the chance to add the block into the blockchain. Okay. So why is cryptocurrency valuable? Since the value is highly fluctuating, what is the true value of cryptocurrencies? Like the US dollars is based on the market's dictation on the currency trust of the people and assets of the. Yeah. So why is cryptocurrency valuable is because you don't have to be dependent on the government. So the fact that now, economically we are going entering a bad situation, we are entering recession very soon. We are going to enter recession. If you know, many startups have recently received notices to go in a do or die situation, stay alive mode, because of lack of funds, and probably that is because of high liquidity. So basically the currency value depends upon the liquidity, how much note is being minted, or how much amount of note has been created and pushed out there in the markets. Okay, so more the number of currency that has been created, less the value. Okay, so governments can keep on creating new notes and push it out there in the market. So you might be holding $1 and the price can go down. Like you could probably buy chocolate using or a toffee using $1. If the government publishes or mints more and more currency, the value will go down, and probably you can buy one chocolate or one toffee using $1. Okay, the price goes down, the value goes down actually. So that is the problem with the typical fiat. But when it comes to cryptocurrencies, there is no central entity who controls the entire liquidity. It's basically the people part of this network who control what amount of Bitcoin should be minted, what should the price of the Bitcoin be. So if everybody is holding, there is a positive sentiment in the Bitcoin community, the prices will stay up. So if everybody is panicking and selling it, the prices will go down. It's completely dependent upon the people who hold this cryptocurrency. Okay, so if you are positive, the sentiment is positive, we are holding this Bitcoin, then we are in a good situation. And we decide whether we want to mint more Bitcoins or mine more Bitcoins. No government or no central entity can decide that we want to publish or mint a million more dollars. Okay, that's not possible. So no central entity has control. It's democratized. Okay, everybody has equal power to decide whether new Bitcoin should be mined or not, and what should be the value. So that is good thing about cryptocurrency. So now there are services actually which like allows you to buy things and like get services using cryptocurrencies. There are like that the option has started, but it's in a very early stage. Or else there are marketplaces where you can go out there and sell this cryptos and get it converted to fiat currency and use that fiat currency to buy a product or service. Okay, that's it. So we are sort of deviating from our core part and moving to a lot of a crypto side, but I want to cover that. I'll cover clear your doubts at the end. Okay, let's to the focus on the core technology now. So proof of work. So proof of work is because there is a possibility of people spamming the network, or everybody adding data into the network, adding malicious thing on the network. What we do is first come first serve basis. Sorry, and the criteria is that you will be given a puzzle. So whoever solves the jigsaw puzzle first gets the chance to add a block or add a data into the block and mine that block. So if you come second, sorry, bye. You have only the second. You can only look at adding the successive blocks. Okay, can't add the current block. So your chance at adding a block depends on how fast you can solve the puzzle. It's like a jigsaw puzzle, but actually it's not a jigsaw puzzle. It's a mathematical puzzle or a computational problem. So basically, if it's a Bitcoin, it will take around 10 minutes to solve the current Bitcoin algorithms puzzle. And the first person who has the maximum computational power will get the chance to solve it and get the chance to add the data into the block and mine the block. And he will run away with the reward. Okay. So that is how it works. So here you have to solve puzzles. So that is proof of work. So you have to show that you have done some sort of work, and you have to show that proof. Once you show the proof, you get the reward and you can go. That is how this consensus system works. And this keeps in spam and malicious activities in check. So next is proof of stake. Okay, so everybody doesn't have enough computational power to add block into the blockchain. Okay, huge GTX or RTX rigs, not possible, and huge amount of electricity is being wasted to mint new blocks in Bitcoin and similar networks. Okay, we want to avoid that. And there is also a chance of centralization, like rich people can buy more and more computational rigs and they can keep on minting new blocks in Bitcoin network and keep on earning rewards, and the poor people with mediocre computational power will sit there, they will not get a chance to create new blocks. Okay, to avoid that, we came up with a new solution called as proof of stake. Here what we do is, you go out there in the market, you buy a cryptocurrency, maybe one Bitcoin or one token, and what you will do is, if you want to become a person who can mine a new block, you will tell the, I have one Bitcoin, I'm ready to become a miner. So you have to put that one Bitcoin as a security deposit. Now you'll get, now the system will randomly choose from all this interested people and select one guy to become the miner. Okay, and this one guy can add the data and add the block into the blockchain. Okay, so you have to first put a security deposit and randomly a person will be created. So here the chances of centralization or chances of only one single person getting the complete control is totally avoided. And at the same time, because there's a feature where, because you're putting a safety deposit, if you try to add a malicious data into the block or into the blockchain, if you try to do a wrong thing, and if the community or the people find out that you're doing something wrong, that is not actually good for the network, they will report that and you will lose your security deposit. And in case you actually do good thing, then what you will get is, you will get your security deposit back with the additional reward also. So if you put one Bitcoin as a security deposit, you will get an additional one Bitcoin as a reward. So in total, 2 Bitcoins back. You do a good deed of adding the right thing into the blockchain. Okay, so here it is far better than POW. So no wastage of electricity, no complicated rigs, computational rigs and setups. So better energy efficiency, low barriers to entry, so anybody can enter, no hardware requirements, stronger immunity to centralization. So sorry, no central entity can take the complete control, and stronger support to shard chains. So shard chains are different concept, different technology that is like that has gained traction recently due to the scalability issue of blockchain. So if you want to know that, please feel free to reach out to me. That's a different session, entire different session. So I'll cover that if you want. Then there is DPoS. So everybody might have the money to go out there and buy the cryptocurrency to get a chance to mine a block and earn the rewards, but everybody doesn't have time to do that. So to avoid that, there is a facility where you can delegate somebody to become a miner and put the security deposit in the name of that person. So the person who has the maximum number of security deposits in his name will get the chance to become a miner, and he will go and do the good deed and add a block into the blockchain, and he will get the reward, and he will come back and he will share the reward with you. So that is DPoS. So you delegate somebody to do the work when you actually don't have the time to do that, or you are not ready to put the efforts. Okay, that is DPoS. So I've covered the basically 3 consensus mechanisms: POW, POS, and DPoS. Okay. Next. So what is decentralization? This is one of the important things about blockchain. That is why we are running behind this new space. And what exactly decentralization is? That means the entire network is distributed among all the people who are participating in this network. Now, a few months back, there was a huge social media outage where Facebook, Instagram, WhatsApp, everything went down. Okay. The reason behind that, we are dependent on a central entity as well as a central server. Okay. So somewhere in the US or somewhere in the East Coast or somewhere in Asia, a server is running the entire operations or the entire data movements of this Facebook or Instagram. So if something happens, a disaster or a calamity, or a hacker targets this, the server goes down, you are affected. Okay, that's the problem with the central entity. And at the same time, because a central entity is having complete control, they are spending money to run the servers, there is a huge chance that this central entity can steal your data. And the best example is the Cambridge Analytica issue that happened a couple of years back with the Facebook. Okay, so that is a problem with central entity. There is a dependency. You have to trust a single entity. At the same time, chances of the entire service going downtime, and your data getting stealed. Single point of failure, hacker has to only hack the server, even though it's very secure, but hacker only has to hack a single server to get access to your entire data or breach the security. Okay. So, but when it comes to blockchain, entire blockchain is P2P or peer-to-peer or decentralized. So we, who are a part of this blockchain network, run this entire network. Okay. This is P2P. So that we are powering this network using our mobile computing power or computational power, whatever it is, using our internet. We are the ones who power it. So consider if we build an Instagram based on blockchain, so millions of people who are the users will be powering this entire network. So you are not you don't have to be dependent on a single entity who is running the server. So even if the server goes down, you don't have to fear. And if it's on a decentralized system, consider if even if a million people go down, if they are facing any outage, the other 90% people are running this network. So the service is still running. Even if it might be slow, the 90% people are keeping this service up. So that is the beauty of decentralization. So there is no dependency on any single entity. There is 100% uptime, 0% downtime, and 100% uptime. And also, there is one good thing that you can't hack any data because there is no single point of failure. Your data and your everything, your entire service is distributed among millions of people who are powering this service. Okay, so you have to literally hack all these millions of people. That's not possible at all. Okay, because the fact that all this data that has been stored in with each and every each and every person in this network is secured using something called as SHA-256, secure hashing algorithm 256. It is very secure, so you don't have to fear that your data will be your data will get stolen, or what you call anything your data can be manipulated or tampered. That's not possible. Okay, that's the good thing about decentralization. Very high reliability, very high security, no dependency, and 100% uptime. Okay, so that is a good thing about decentralization, and blockchain facilitates that. Okay, then there is smart contracts. Now, Bitcoin brought this good thing about finance to us. Now we have a better banking system based on Bitcoin, better transaction system, open passbooks. You can't fool anybody, no banking frauds or anything. If you have Bitcoin in your wallets, you can buy things, or if not. And that was a good thing about that. Jobin, can take some more time. I'll shift the workshop. Yeah, sure. That would be great. Yeah. So I'll try to quickly cover everything and wind up the session. I don't want to lengthen it, stretch it, and make it a boring session. I'll quickly cover up. Okay. So what are smart contracts? So Bitcoin had these good things about decentralization, reliability, decentralization, security, and everything, transparency. Transparency, I told you, because your wallet is transparent. Everybody can look at what your balance is. So you can't fool anybody that I have more than 5 Bitcoin and I'm ready to spend more. You can't fool anybody. And whatever transactions you do is open out there on the internet, so everybody can verify that. So it was open, it was transparent. At the same time, your personal data, such as your identity, can be completely hidden using SHA-256. So it was also facilitating privacy at the same time. So I call it open, trustless, and permissionless. Okay, the permissionless part comes here because of smart contracts. So what exactly smart contract is? Bitcoin only allowed you to leverage blockchain's technology in terms of finance, but smart contract expanded the possibility, create a huge platform for you to build a lot of things. How? So Ethereum was the one who brought smart contracts after Bitcoin. Bitcoin didn't have anything like smart contract or programmabilities, but Ethereum brought this thing called as smart contracts. So what this allows you to do is that smart contracts are nothing but basically this is a program which takes a certain input and gives you a certain output. Okay, very simple program. So if the input criteria is met, so whatever the output was decided, it will be given to you. Okay, as a user, you will receive that. Okay, so a best explanation, or a best example that I can give to you is a crypto vending, a Coca-Cola vending machine, a Coke vending machine. So you put probably what do you call? I'll give you an example of a dollar. You'll put a dollar in your Coca-Cola or Coke vending machine, and if that's the value of a Coke can, you will get that Coke can dispensed. If not, you will. If the money is less, will not get a can dispensed. Okay, so basically the machine has been created in such a manner that if the input criteria is met, then the output will be given. Sorry. Okay, so smart contracts are programs where input and output is present, and it's completely automated. So if the input criteria is met, the output will be given. So you don't have to depend on anybody. So that is one good thing I was talking about. Dependency. Blockchains allows you to be independent. You don't have to depend upon any single entity. Like there was an issue with Twitter where Trump was kicked out of Twitter. That's because the central entity was controlling it. So Twitter was deciding whether Trump should stay on Twitter or not. Okay, we were not liking his tweets, we are hating it. So let's just kick out Trump. So probably if somebody creates a blockchain-based Twitter solution, so we can bring back Trump. Okay, I don't know how much of you, like how many of you guys love or hate Trump. That's a different thing. I was just trying to give you an example about that. Okay. So here, nobody gets a chance, or no central agency get a chance to tell whether you should stay on the internet, or you should stay on this platform or not, or use the service or not. If the criteria is met, you will stay on the internet. Okay, and the community also has a chance to decide whether you are doing a right thing or not. You should stay on the network or not. Okay, that's another thing. Okay, so whenever you hear the word called as smart contracts, just remember the example of Coke vending machine. Okay, you put $1, the price of the can is $1, the Coke will be dispensed. Input and output. Input criteria met, output is given out. Okay, so the smart contracts are written commonly in a language called as Solidity. It's very similar to JavaScript and similar sort of languages. Okay, so you can write a small smart contract in probably in what do you call, even in 10-15 lines of code. Now you can see one simple explanation of storing a data and fetching that data using Solidity, and smart contract is given out there on the screen. You can check that. Okay, so it's a pre-programmed dispensing machine. That's the best example or best definition that I can give you for smart contracts. Okay, so that is written using Solidity. Another couple of another languages that facilitates writing of smart contracts are Solidity, and then is Viper, then is Rust, and a lot more coming. Okay. So that is smart contract. Then the next thing. Okay, so smart contracts were essentially just programs. So I don't think so. We as a developer will be able to interact with this program and get the output by feeding in the input. But what about our grandparents or our mom and dad who probably are not familiar with programming languages, or maybe a non-engineering or a non-developer guy? How are they going to interact with this smart contract? How are going to use a blockchain-based application? That's not possible, right? So it looks like just the machinery behind the Coke vending machine. So you'll not be using a Coke vending machine if it only has the circuitry and all the machinery parts, the mechanical parts. Okay, you are not going to use that. You want a proper Coke vending machine with a proper refrigerator and the cans placed in that, and a glass and the proper painting and everything. Okay, a proper interface. That's the right thing I can say. A proper interface. Not exactly. This program is actually written in Solidity that you see on the screen. Okay, not Rust. So you can also learn Rust, and that's also a beautiful language. It's a bit difficult than Solidity. Solidity is far easier than that. Okay, so smart contracts are the core technology or the essential machinery which facilitates the logic or the functioning of this program. Okay, but you need an interface for you to interact and give the input and get the output. Okay, you need that. So for that, what you have to do, you have to build a front end using HTML, CSS, React, JavaScript, Vue, Angular, whatever language or whatever stack you like. You can learn that and you can build a front end using that. You write a smart contract to store a data or dispense a Coke can, or dispense a Netflix movie or a series. You can do that. Okay, create a program using smart contract with smart contract using Solidity. Now you want a front-end interface where you can come and pay $1, $2, whatever the amount is, and download that Netflix series or a movie. Okay. To allow that, you need a user interface, and that user interface can be created using HTML, CSS, JavaScript, React, or whatever it is, whatever language you are familiar with or comfortable with, you can use that. So when you combine, sort of, this is like the when you combine the smart contract, the logical part, with the visual front end part, when you combine this thing, it creates something called as dApps. Okay. Typically, when it comes to the conventional applications, the logic with the front end part creates applications or apps. Now, because it's smart contracts with the front end interface, when you combine both, running on a decentralized blockchain network, it is called as dApps, or decentralized applications. Now, what is the good thing about decentralized applications? It is automated. It has zero downtime. It has every good features from the blockchain or the Bitcoin part: better privacy, censorship-free, complete data integrity, verifiable behavior, better privacy, transparency, open, trustless, permissionless, everything. Permissionless because it's automated. You don't have to get permission from anybody. If the input criteria is met, the output will be given out. Trustless because you don't have to rely on any central agency or entity that, yeah, this guy is storing my data safely, like Google or Dropbox or anybody. Because it's distributed out there in the internet or in the entire network, and it's secured using SSH 256, it's completely safe and secure. So you don't have to trust anybody. It's completely automated, trustless, and open, censorship-free, better privacy, zero downtime, integrity, okay, everything. So I hope that I've covered the essential part of that. I know how to front end already. What else do I have to learn for making dApps on Solidity, or is there more? I'll come to that, but I'm going to share to you something really cool, using which, even if you don't know front end or HTML or CSS, you don't know everything, anything about programming or development, I'll share such a content using which you can get started from scratch, and within a month or two, you can probably become a blockchain developer and engineer and build your first dApp, or write your first smart contract, or build a NFT marketplace, or mint your NFTs or anything on blockchain. Okay. I'll share that content at the end. So stay tuned. So that is dApps. So then there is this era of Web. So I told you, I call this as OTP. It is one of my ways of saying OTP, open, trustless, and permissionless. So Web3 is OTP. So Web 1.0 was the first generation, which was dedicated infrastructure or e-commerce like Amazon and everything. And then there came the Web 2.0 era, like from 2005 to, I believe, 2015. There was Web 2.0, the social media, mobile-driven, cloud-first, all these things were Web 2.0, like Airbnb, Uber, all these things. Then there came Web 3.0, which is more automated, less dependent, more robust, more smart. Okay. And this Web 3.0 this generation of internet is powered using AI, decentralized data architecture, edge computing, machine learning, and what do you call blockchain. All these technologies are what power Web3. Okay. So the good thing about Web3 is, you don't have to depend on any single entity. Your data is completely safe, and everybody who is a participant on this internet can earn. And there is a low possibility of spamming also. Now, because I've shared how the consensus works, there is a low probability of spamming the network. So this is Web3. So next, there is Ethereum. I told you Ethereum is the blockchain network that brought smart contracts into play. And in Bitcoin, the BTC was the currency for doing all the transactions. But in Ethereum, it's ETH or Ether. So using Ether, you can do all the transactions in Ethereum. Okay. So that is done. I'm not going to read that. Coming to the applications part. Okay. So there are 5 major verticals: supply chain, finance, healthcare, retail, and government. Okay. So just think, if you buy something from Amazon, and if it's based on blockchain, you can track each and every moment of this package. And also at the same time, if you receive a wrong package and you request for the return or a refund, you'll not have to wait for 5 to 6 business days for the refund to be initiated and to reflect in your bank account. If you build a smart contract that you upload a photo of the package that has been delivered to you, and if the photo, probably it can use a machine learning or AI to understand that actually the product is the image that you have shared is of a product or not. If it is true, then it will reject the refund. If it's not true, the product you have received is not the right product, then the machine learning will tell the smart contract the input is true, the customer has received the wrong product, and instantly the output, that is refund, will be initiated. So there is no middleman involved. You don't have to call the Amazon customer care, or you don't have to initiate any refund request or return request or anything. Okay, completely things can be automated. So also when it comes to finance, just think there is no banking. You don't have to visit bank for loans or anything. If you have anything to put out, like give out as a collateral, we'll just take a photo of that, make a PDF, just submit that to the smart contract. Smart contract will verify based on your financial stability, your financial score, or experience score, or your collateral that you have submitted. Based on that, if the input criteria is met, it will instantly disburse your loan amount, and you can enjoy your money. You can use your money. No middleman, no interest rate, no high interest rate, no processing fee, no headache. Okay, that is good thing about finance based on blockchain. Then there is healthcare. Out there in the healthcare industry, health data is very, very costly. So your valuable health data can be stored and secured in a blockchain-based data management system. So the pharmaceutical companies and healthcare research companies don't get access to your healthcare data. Okay, not even the insurance companies. If you don't decide that you don't want to share your personal health data with the insurance companies, you can avoid that. You can decide when you want to share that. Okay, so then there is retail, better inventory, faster settlements, less paperwork. That's one of a good thing. Right. Also government, transparent processes, improved implementation, better control. Just imagine I gave you an explanation of DPOs where you delegate somebody to do the validation or do the mining of creating a block in a blockchain. Similarly, you can use a DPO system to create an election system out there in US or in India or in Saudi, or anywhere. You can create an election system based on DPOs. Just think how good it will be. Everybody can check whether it's transparent and who has voted who and was the majority. So there is no chances of what do you call fooling people or fake vote an election. Okay, there is no possibility of that. It's a completely transparent and completely secure. At the same time, also you can make that privacy focused. Like you can secure the personal details of this voters. That is also possible. And also applying for visa or passport or citizenship or anything also can be automated completely using a smart contract. Okay, so you share all this required criteria, you submit all the documents, and the input criteria is met, you'll get your passport, or you will get your visa, or you'll get what you call citizenship, or whatever the document you want. You can get that using a smart contract. It will be completely automated. No middleman is involved. No processing time. Instantly, within a day or two, or even within hours, you will get your paper or your documents done. So that's all, folks. That's the entire fundamentals of blockchain. How we get what's smart contracts, what is blockchain, what are the consensus, what is Web3, what are dApps, and we can build a dApp. Okay, like what's the core concept behind that. So now what I'm going to do is I'm going to share something. So I basically work for Arcana. So I've wrote a lot of articles, and I also recently wrote something called let me just called as a Web3 developer roadmap. Okay, yeah, this is. I'm going to share that in the chat section. This is a complete Web3 developer roadmap where you can learn from scratch. Even if you don't know front end, HTML, CSS, or anything, even React.js, JavaScript, you don't know everything, the prerequisites and all the content also is given there. You have cryptography, the fundamentals of blockchain, Bitcoin, Ethereum, white paper explained in a simple manner. Then there is Ethereum part, smart contracts, it's smart contract lifecycle. How you can write your first smart contract using Solidity, the patterns, how you can secure your smart contract, how you can build your dApp, its architecture, and also a couple of projects, which after learning all this content, you can actually try this out, build some cool projects. And I've made sure that you have multiple types of content for each and every section. Like if you are looking at cryptography, I've added an article to read about cryptography. I've added an exhaustive list of cryptography with practical examples if you want to look into that. And if you are not a guy who loves to read, if you want to play a game and learn learn the cryptography part of blockchain, visit this part. So I've made sure that in each and every section I've added articles, videos, advanced, beginner level content, also games. I've also added something here called as, there's a DApp part. Yeah, crypto zombies, where you can actually learn to build dApps by playing simple games, and actually you will also be rewarded with NFTs when you complete each and every level. Okay, so I've made sure that this roadmap is very interesting and pushes you forward to complete each and every level and build some dApps or mint NFTs or write your first smart contract. So that is possible. So that's a good thing that I want to share. And the thing is that if you wish to learn more, if you want to reach out to me, here is my profile. That's my Twitter. So I'll share that. Feel free to reach out to me anytime. If I'm available, we can sit on a call. You want to chat with me, or you want to learn development, build your first blockchain, write your first smart contract, dApp, or anything, feel free to reach out to me. You can follow my content also. I'll be happy to help you out in becoming a blockchain developer or a blockchain engineer or a smart contract developer. And at the same time, also, I'm working for Arcana Network. So when you actually build a blockchain-based application, when it comes to storage and authentication, setting up storage and authentication solutions is very troublesome. A lot of code is involved. I'm only, why am I sharing it here is because many of you might be new to this space. And when you're actually trying to build on blockchain and trying to look out for storage and authentication solutions, the implementation of code is very complicated. But if you actually use our solution, give it out a try, and I'm damn sure that you'll be a fan of it, because out there other solutions probably take a day or two for you to implement and set up and integrate all these things. But when it comes to our solution, it just takes you 30 seconds. Yeah, literally just 30 seconds for you to set up the, what do you call, the storage and the authentication part. Just 30 seconds, and I believe 3 or 4 toggles. Okay, I'll quickly show that. If you want to implement, if you're planning to build something, feel free to reach out to me. I'll show that. You can visit this dashboard. I'll just delete this. Give me a second. And actually remember the password. It's just, sorry guys. Yeah. Confirm. So this is, I believe, for you to get started as a new beginner blockchain developer. This is the best storage and authentication part. If you are trying to store NFTs, if you want to store the files in your application, then this is the best part. Like, I'll show you. Visit this website, dashboard.arcana.network. Click on configure, type in your name. I'm going to type in Hack3. Just type in Hack3, and then choose next. If you want to decide, if you don't want to play with the location, if you don't want to play with the chains also, then click on next. If you want authentication in your application, you can choose. If you want Google, if you want GitHub, Reddit, Discord, or whatever it is, you can decide what you want. If it is Google, just visit this link and copy paste your client ID, and you're done with your authentication. And then click on next. And at the moment, it's completely free, and there is no unlimited bandwidth on your storage and authentication. And that's it. I think it barely took me just 10 seconds to set up the blockchain-based storage and authentication part. And your blockchain projects, authentication part and storage part is done. So you don't have to worry about anything else. So right now, come here, you can check the number of users, number of files, what amount of storage has been used, download, upload, shares, transfer, revokes, and everything. Okay. So that's how simple it is to set up a storage and authentication solution using our service. So if you wish, you can build on this, and feel free to reach out to me. I can help you with the integration. And if you build a really cool thing, DM me the link to the project. We'll be happy to give you grants to actually make this project, expand this project, and probably make this a startup or an open source project. Feel free to reach out to us. We give out grants for great projects. We'll help you mentor. We'll mentor you to turn this out to a great project, a successful project. We'll help you with that. Feel free to reach out to that. Okay. And yeah, so Srinivas, yeah, we can wrap up this thing. If you can share the emails with me on email, then I'm going to do one thing. All these people who have attended today's session, I'll try to ship out some swags, stickers or t-shirts or bottles, something to you. And one other thing is that if you have any feedback about the session, how the analogies were, how I explained this blockchain concepts and everything, how it was it good? Feel free to share the feedback with me, tagging me and Arcana on Twitter. Okay, so I have shared my personal Twitter account. So I believe that I've shared, I've shared my Twitter account with you. So you can reach out to me, you can share your feedback. I'll be happy to help you out with that, and I'll be really happy if you share the feedback. Okay. Zainab, you can share to Srinivas, or you can share in the you can share in the chat section the email. Okay. So if you can share the feedback on Twitter, I'll really appreciate that. Okay. So yeah. Go ahead, please. Anything to ask?
All right, so thank you so much, Jobin, for your wonderful workshop. It was very informative. In my opinion, your analogies and how you explain the blockchain was really useful and something that I'm going to take more. I personally will try looking more into and use. So thank you so much.
Yeah. And thanks for giving me this opportunity to host this workshop. And thanks all those guys for joining this session. Feel free to steal the swag, share your email IDs. I'll ship some cool swags to you. Okay. Thank you. Have a good day.
All right. Thank you, everyone. Have a good day.